Welcome friends, in this video we are going to look at science paper 1 for the year 2011. Now we have this question 1. So a cyclist accelerates uniformly from rest to a velocity of 10 meters per second in 3 seconds. He then moves with a constant velocity of 10 meters per second for 6 seconds before decelerating uniformly to rest in a further 5 seconds. Okay, so draw a velocity time graph representing the cyclist motion. Okay, so let's see what we are supposed to do here. So we are supposed to draw the XY plane. Now under this one we are dealing with a velocity time graph. So a velocity time graph, the y-axis represents the velocity, while the x-axis represents the time. So since this cyclist began from the rest position, we are always going to start with 0. Now first we need to understand what is meant by the given data that we have here. So we have velocities in meters per second, then we have time in seconds. So let's go back to our point. So a cyclist accelerates uniformly from rest to a velocity. So the highest velocity achieved by this cyclist was 10 meters, and this velocity was achieved in 3 seconds. Okay, then after that we are going to have a horizontal line, or a line parallel to the x-axis. So he then moves with a constant velocity of 10 meters for another 6 seconds. Then after that we are going to have deceleration. So we need to come up with the scale that we are going to use. So under the y-axis we can use, let's just use 2 centimeters to represent 2 units on both axes. Okay, now for this one, okay, let's just say 2, we have 2, 4, 6, 8, we have 10 here. Then we'll do the same in the x-axis. So we have 2, 4, we have 6, 8, 10, we have 12, 14, up to 16. So the first one we are going to plot is 0, 0. Where is this 0, 0 coming from? This 0, 0 is coming from the word rest. So whenever you have rest, it means the initial velocity is 0. Then after that we need to plot 3, 10. So this 3, 10. So let's look at where we have 3. So 3 is between 2 and 4. So 3, 10 is here. So this is where our 3, 10 is. Then when connecting a line, we have to make sure that it's a straight line, since the point is the acceleration was uniform. So we need to draw a straight line. So this is our initial point here. Then we have our final point here. So final velocity. Then what happened after this final velocity? We are told he then moves with a constant velocity of 10 meters for 6 seconds. So from this point here, let's call this point B. From point B up to point C, we need to count 6 seconds, and this line must be parallel to the x-axis. So we'll say if this is 0, so we'll say 1, 2, 3, 4, 5, 6 is somewhere here. So we are going to draw a straight line up to here. Why? Because we are told a constant velocity. So whenever you are dealing with a constant velocity, make sure you draw a straight line parallel to the x-axis. Then from there we are told before decelerating uniformly to rest in further 5 seconds. So we need to look at where we're supposed to put our 5 seconds. Okay, so from this point, let's say this is point C, from this point up to point D, we need to move 5 seconds. So say, so if this is, so say 1, 2, 3, 4, 5. So I'm going to draw another straight line, but this line must be slanting down. The reason is slanting down because we are told this is the deceleration part. So this person decelerated and came to rest after 5 seconds. So from point C up to point D, the time taken was 5. Then this is our acceleration here. So this is what we are supposed to do for this part. Now let's go to question B. Calculate the distance traveled by the car during the journey. So this is the total distance, and if we can see, we are dealing with a trapezium. So the trapezium is given by half, then we have a plus b multiplied by the height. So let's now identify the value of a, b, and h. So the value of b is this line from 0 up to 14. So this is our b. Then our a is this number on top, so from here up to here. So this is our a. Then our h is from 0 up to the highest velocity achieved. So the a value, the a value, if we move here, we have 3 up to 9 here. So 9 minus 3 is 6. Then b, we get the 14 value. So distance is equal to half. Our a is 6 plus 14. Then our height is 10. So we can just do the math here. 6 plus 14, we have 20. Multiplied by 2 here is 1, 2 here is 5. So times 5. Then if we multiply 20 times 5, we get 100 meters. So this was the total distance covered during this journey. Let's move on to question 2. So question 2a, what is meant by the center of mass of an object? So the center of mass of an object is a point where the mass, the entire mass of that particular object is considered to act or is concentrated. So say this is the point. On or in an object or its entire mass seems to act. Then for question B, explain why a minibus is more likely to top over with the roof when the roof rack is heavily loaded than when the roof rack is empty. So whenever you put too much of luggage or certain things on top of a roof, like here, we are just increasing the center of gravity or center of mass. So whenever the center of gravity increases, then the stability of that particular object decreases, because we know that if we want to increase the center, the stability of an object, the center of mass must decrease. So whenever that happens, then the point of this topping over also happens. So we'll say because the center of gravity increases, which results in a decrease of the stability. Okay, we move on to question C. A meter rule is supported on a knife edge placed at the 40 centimeters mark. It is found that the meter rule balance when a mass of 45 grams is suspended from the 15 centimeter mark as shown in figure 2.1. Okay, so now we are told if the center of mass of the meter room is at 52.5 centimeter mark, calculate the mass of the meter room. So we are going to use the principle of moment. So say this is our moment 1, then we'll have moment 2. Now we have been given this condition that if the center of mass of the meter room is at this point, so this is where we are supposed to consider the mass of this meter room is concentrated. So let's say at this point, this is where 52.5 centimeter is. So this point represents the mass of the meter room. So the distance from 40 centimeters up to 52 centimeters, this will be considered as the distance 2. Then the distance from 15 centimeters up to 40 centimeters, this one will be considered as the distance 1. Then at this point is where we put as the pivot. So the distance is always measured from the pivot up to the point of action. Then the point of action is the point where a certain weight or mass is hung. So let's now apply moment. So we'll say moment 1 is equal to moment 2. Then the formula for moment is equal to force times distance. Now since we are given mass, we just say mass 1 multiplied by distance 1 is equal to mass 2 times distance 2. So mass 1 is the mass that we are given, and for this one no need of converting, we can just use the mass in grams. So we have 45 grams multiplied by what is the distance from here up to here. So from here up to here is 15 centimeters. So we can just find the difference between 40 centimeters and 15 centimeters. So it is 40 centimeters minus 15 will give us 25 centimeters is equal to mass 2 is what we are looking for. Distance 2. Distance 2, we need to subtract 40 from 52.5. So I'm getting 12.5 centimeters. So we can divide by 12.5 centimeters. Here also 12.5 centimeters, so that if we cancel, we have M2 is equal to, so 45 multiplied by 25, I'm getting 1125, then divided by 12.5, so I'm getting 90 grams. So this 90 grams is the mass of the meter. So this was the mass that was here. And if you multiply, let's say 90 times 12.5, I'm getting 1125. So this moment, the moment on this side is equal to 1125. Then the moment from this side is the same, which is 1125. So since these two moments equal to each other, then we can conclude that this illustration here is in equilibrium. Okay, we move on to question 3. A girl whose mass is 45 kg carries a box of mass 25 kg up a flight of steps. There are 40 steps, each 40 centimeters high. She takes 16 seconds to climb up the steps. Take gravity is equal to 10 meters per second squared, which is the acceleration due to gravity. The first question is what is her weight? So we know that weight is given by the product of mass and gravity. So the weight that we are looking for is for the girl. So we use the mass 45 kg multiplied by 10 newtons per kg. So we can cancel. So the weight is 450 newtons. Okay, then for B, what is the weight of the box? The formula remains the same. We are just going to change the mass. So the mass of the box is 25 kg multiplied by 10 newtons per kg. So here we get 250 newtons. So make sure whenever you are calculating weight of an object, make sure that the mass is in kilograms. Okay, let's check for question C. Calculate the total gravitational potential energy of the girl and the box when she reaches the top. So potential energy is equal to mass times gravity times height. So the mass is given. Now this time we want the potential energy of the girl and the box, so we are supposed to add the two masses. So the mass of the girl is 45 plus 25. This will give us 70 kg. So we have the mass. Then what of the height? So the height is, there are 40 steps. Then each has 40 centimeter high. So what are we supposed to do? We need to multiply the total number of steps times the height of 1. So 40 times 40 centimeters high. This will give us 1,600 centimeters. Now the height used whenever you are calculating potential energy must be in meters, so we need to convert. So we know that 1 meter is equivalent to 100 centimeters. Now what is 1,600 centimeters in meters? So we just cross multiply. So we have 100 centimeters x is equal to 1,600 centimeter multiplied by meter. So to summarize, the point here is that whenever you are converting from meters to centimeter, just divide by, from centimeter to meters, just divide by 100. So the height in meters is 16 meters. So that is the one that we are going to use. So we'll say potential energy is equal to, we have 70, then multiply by, what's our gravity is 10. 70 is the total mass of the box and the girl. Then the height is 16. So we can now multiply 70 times 10 times 16. So I'm getting 11,200 joules. Now if you look at the formula for this potential energy, will give us the so let's say potential energy can be equal to, so if you look at the weight, the formula for weight is equal to mg. So the potential energy can also be weight multiplied by the height. So do we have the total weight? Yes, we have the total weight. So the weight of the girl is 450 plus the weight of the box is 250, adding up to 700. So here we have 700 multiplied by 16. So 700 times 16, I'm getting 11,200 joules. So the point is, if you want, you can find potential energy by multiplying the weight times the height. So that's what I wanted to share. Then for question D, calculate the total power. So power is equal to total distance. So distance divided by time. So not the total distance, but power is equal to work done. So work done. Now work done in our case is just the potential energy, so it's 12,200 joules. Then divided by the time. Time is given from the first statement. We are told she takes 16 seconds, so we are going to use 16 seconds as time. So use 16 seconds. And this 11,200 divided by 16. So I'm getting 700 watts as the power. We move on to question 4. Question 4a. The diagram below represents a bar of soft iron which is to be magnetized with a north pole at end A. So here, this is where our north pole should. Then here we are going to have the south pole. Okay, so if that is the case, then the question is complete the diagram to show how we arrange the coil connected to a cell to achieve this. Make clear on your diagrams the windings of the coil and the polarity of each cell terminal. So here is where we're going to put our positive terminal. So we can now put our windings. So this is where our negative. So this is the flow of current. So this is our diagram that we are supposed to use. Then let's look at question B. What would be the effect of disconnecting the cell on the magnetization of the bar? So say the bar would start to lose its magnetism. The reason why we are saying the bar would start to lose its magnetism is because the type of metal that was used was iron, and we know that iron forms what we call a temporal magnet. That's why we say iron is easy to magnetize and easy to demagnetize. So the process of demagnetization will start taking place after the disconnection is done. So that's what we have. Also, if you want to, we can just say the bar will start undergo demagnetization because it's easy to demagnetize. Okay, we move on to question 5. The pressure of air in a tire of an empty lorry is 3.0 times 10 to the power times 10 to the power 5 Pascal, and the volume of the air in the tire is 0.08 meters cubed. Calculate the volume of the air in the tire when the lorry is loaded until the pressure of the air in the tire rises to 3.6 times 10 to the power 5 Pascal, assuming that the air temperature is constant. So here we are going to use the formula, one of the gas laws here. So the formula that I would recommend you to master is PV is equal to T. Now for this one, T is constant, so we need to get rid of T. So how can we do that? So in case where you don't know these formulae, so how can you make the formula that you are using? So the first one, make whatever factor constant, the one that is constant, the subject of the formula. In our case, we have T, the subject of the formula. So where there is T, we replace with whatever that we have. So the actual formula is PV is equal to PV. So say 1, 1, 2, 2. Then we can do the substitution. What's our pressure? So the pressure, the first one before the loading was done, the pressure was 3 times 10 raised to the power 5. Then volume 1 is 0.08 meters cubed. Then pressure 2. Pressure 2 is given this one, 3.6 times 10 to the power 5 multiplied by volume 2 is what we are solving. So let's say we raised to the power 5 multiplied by 0.08. So I'm getting 24,000 here. This will just be 3.6 times 10 to the power 5 not V, so V2 over 3.6 times 10 to the power 5 over 3.6 times 10 to the power 5. So what's our volume 2? So divided by, we have 3.6 10 raised to the power 5. So I'm getting 0.067 meters cubed. Now let's look at what happened here. So pressure 1 is 3.0 times 10 to the power 5. Pressure 2 is 3.6 times 10 to the power 5. So pressure 2 is greater than pressure 1. Let's look at pressure 1. Volume 1. So volume 1 is 0.08 meters cubed. Then volume 2 is just 0.06. So we can see from the data that we have here that the pressure increased, then the volume decreased, because this volume is greater than this volume. So whenever the pressure increases, then the volume must decrease. So the relationship between pressure and volume, given that the temperature is constant, is that these two are inversely related. Then we move on to question B. The tire pressure of a lorry that has been moving for some time is usually greater than the pressure when the lorry has been standing at rest. Why is this so? So what I want you to have in mind is that whenever a lorry or a car is moving, there is a friction between the ground and the tire. So that friction creates the heat energy. So that heat energy will cause the gas in the tire to expand. So the expansion of the gas, the expansion or the increase of the energy in the particles in the tire increases. Because of that, the pressure increases. Because the pressure of a gas all depends on the collision of particles with the tire. So say because the lorry that has been moving, for some times. So because the lorry that has been moving for some times has high pressure due to increase in temperature of the particles. So this is just done by the friction. Then question 6, two successive crests of an approaching water waves are separated by a distance of 1.5 meters. It takes 0.2 seconds for one crest to cover the distance of 1.5. Then question A, at what speed is the wave traveling? So we know that speed is equal to distance over time. Now one crest has 1.5, so to make one complete wave we need these two. So if from here is 1.5, even here is 1.5, so the total distance is 3 meters over. Now we know that this one crest is taking 0.2 seconds, so even here we need 0.2 seconds, so the total is 0.4. Then we have 3 divided by 0.4, so I'm getting 7.5 meters per second. What is the frequency of the wave? So we know that speed is equal to frequency times lambda, so over lambda, so that we make frequency the subject of the formula. So we just want to know the number of waves that were produced by one wave. So the speed is 7.5 over lambda. So lambda we said is 3. So lambda is just the distance for one complete wave. So we'll say 7.5 divided by 3. So I'm getting 2.5 hertz. Then see, distinguish between the nature of water wave and the sound wave. So water wave is a transverse wave. Then sound wave is a longitudinal wave. Question 4. A 4 centimeters high object is placed 8 centimeters from a convex lens of focal length 3 centimeters. So draw a scale diagram to find the position and size of the image. So how can we do this? Okay, so we need to draw the principal axis. So first you begin by drawing the principal axis, very important. Now whenever you are doing this, make sure you use the rule for you to get the diagram which is drawn to scale. Then we'll put our lens here. So this is our lens. We have convex lens. Let's just make it as high as we can. Then 2 centimeters, we have 4 centimeters, we have 6 centimeters, we have 8 centimeters. So how can we make our scale? So we just say 2 centimeters to represent 1 centimeter to represent 2 centimeters. So here we'll put 4 centimeters, then we'll put 8 centimeters, then we'll do the same. Okay, let's not show the numbers. Let's not show the numbers. We are just going to indicate the focal point number 1. Okay, so the focal length is 3 centimeters. So let's say this is our F1, this is our F2. Then here we have F3. So we do the same even here, F1 to F, 3F. So this is the principal axis. Okay, so what are we going to do? So we'll say 4 centimeters. So the first one, 8 centimeters from the convex lens. So if this is 3, 6, 8 is here. So this is where our 8 is. So 4 centimeters. Then you draw a parallel line. Make sure it passes through here. Then you draw another line passing through the. Okay. So this is where our image is expected to be. Then position of the image. So position of the image, are we supposed to calculate here? So the position of image. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over, this one is 3, is equal to 1 over 8 plus 1 over di. So we just have to do some calculations. So if we collect the like terms, 1 over 3 minus 1 over 8 is equal to 1 over di. Lowest common denominator, 4, so we just say this times this, so 8 times this one is 8 minus 3 over, we have 24, 1 over di. So 8 minus 3 is 5 over 24, 1 over di. So 5 di is equal to 24 over 5 over 5. So di is equal to 24 divided by 5. I'm getting 4.8. So 4.8 is the answer for this one. Then for size of the image, so we use the formula. For this one, we will need to use the formula for magnification. So say height of an image over height of an object is equal to negative distance of an image over distance of an object. So height of an image is given 4 centimeters. We don't have this one. So height of an image is what we are solving for, over 4 centimeters is equal to negative distance of an image is 4.8 over distance of an object we are given is 8 centimeters. Then we cross multiply. So 8 centimeters, HI is equal to, we have 4.8 multiplied by 4, getting 19.2. So centimeters, another centimeters over 8 centimeters over. So this one divided by 8, getting 2.4 centimeters. And it's making sense if you look at the height of an image is smaller than the height of an object. Then the distance of an image is also smaller than the distance of an object. So whatever that we have said here is making sense. Then figure 8.1 shows a diagram of a clinical thermometer with some features labeled. Explain why it has each of the following features. So the first one, a thin glass walled bulb. So to conduct heat easily. Yes, then we move on to a constriction to prevent a backflow of mercury. Then a short range of temperature calibration to measure a temperature of a human being. Then for D, we have a narrow bore. So say for easy penetration of heat. Then an oval-shaped glass stem for easy observation of mercury. So whenever the mercury expands, we need to observe that. The last one, figure 9.1 shows two metal spheres A and B being charged by induction using a negative charge rod brought near to A. In figure 9.2, the two spheres are separated in figure 9.3, the charge rod is removed. So what should be the nature of material used as a supporter of each sphere? So the supporter must always be, we can say neutral, or we can say insulators. If you don't use insulators, we just have to say bad conductors of heat. So whatever that is supporting this must not be a good conductor, so should be a bad conductor. Then on each sphere separated in 9.1, 9.2 and 9.3 indicate the charge distribution. So how can we look at the charge distribution? So for this one, since this is negative here we are going to have plus, 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 minus, 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 plus, plus, minus, 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 minus. Then for this one, we have plus, 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 minus, 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 minus. Then for the remaining, since these are not connected, the distribution was just even. So this is what we can say for this video. Thanks for watching.